My name is Ben Campbell and welcome back to The Self-Made Theory. My guest this week is Dr. Alex Grant, who's the CEO of a company called Myriota. Myriota are an Adelaide-based tech startup company, and they're developing technology for the space and Internet of Things industry, and have recently attracted US $15 million in Series A venture capital. In this episode, Dr. Alex and I cover a range of topics including how Myriota's technology and IoT is going to change the world, and why, regardless of the patents you hold, the most valuable intellectual property you have in your company is your people. And just because you're an expert in one part of your business doesn't make you an expert in everything. It's such an exciting time in Adelaide and South Australia, and examples like Myriota show us that we have a great future in the technology sector. Enjoy. Well, welcome, Dr. Alex Grant, to The Self-Made Theory.
Oh, thanks. Thanks for having me.
It took us a little bit of time to get this together because you've been a pretty busy man over the last few months.
Yes, yeah, that's right. I guess raising a bunch of capital does that too.
So we'll get into that in a second, but I'm really keen is what's the elevator pitch on Myriota and Dr. Alex Grant?
Yeah, Myriota is all about providing connectivity for the Internet of Things in areas of the world that right now don't have a cost-effective way of connecting all kinds of sensors and devices, mainly focused at businesses. And the things that we deliver are global coverage, a long battery life, and a low cost. So the three elements of a service that those industries in remote areas are really looking for when they're deploying Internet of Things solutions.
So I imagine there's probably a few people that are listening to this that don't understand what Internet of Things is. I do. Can you perhaps give some examples of maybe even use cases on what is the Internet of Things?
Yeah, so in contrast to human communications like voice or video that we're all more or less used to in our day-to-day interaction with the Internet of Things is focused on machines and devices that are using quite small amounts of data for industrial purposes. So what's some examples of that? Agricultural applications like monitoring livestock water in tanks or in troughs, monitoring the livestock themselves, and perhaps even doing things like monitoring broadacre soil moisture levels. So applications where just small bits and bytes of data, but from far-flung and wide areas, have a large impact into improving business efficiency or productivity, improving how you do business. Other examples are things like tracking all kinds of equipment, either for construction or mining types of operations, or for freight and logistics, where that might be easy to do in an urban environment, but as soon as things are going across seas or in remote parts of the world, that's a little bit more difficult. And again, you just may want to know where something is. You might want to know how long a motor or a generator has been running for preventative maintenance.
So if I'm a farmer, so I grew up in Mount Gambier, so lots of friends had farms, both predominantly cattle farms or dairy farms. Yeah. I'm monitoring the livestock, but what am I monitoring? What information are these sensors sending back to me?
So some of the early use cases we've had are things as simple as monitoring the water tanks that fill the troughs that the livestock drink from. Now, livestock drink really hundreds of litres a day, and amongst the whole herd you can really drain a tank, and particularly if that's not being filled from the bore or something's broken, you'll very, very quickly drain a large tank. Now, the way that that's currently monitored in most remote properties is manual site inspections.
Farmer jumps on his motorbike,
gets on a motorbike, drives around in a Land Cruiser, puts a ladder up the side of the tank and has a look.
Yep.
And on larger properties, that can be a full-time job for a station hand, just driving around all day, every day, checking waters. Because you have to do it, but it's a significant cost and time overhead. And you're doing that quite sporadically. So if something goes wrong, you're finding out quite a long time after the fact.
Could be days.
Could be days, exactly. And you've got your livestock that are already in stress from not having access to water. So doing something as simple as putting a water level monitor with a connectivity solution provides a lot of value, and it's really transformational. It's very exciting to interact with the farmers that have got a taste of this now in our pilots, where you can just see it's changing their approach to how they're managing that resource. They're getting the data more frequently, more reliably, and they're getting it electronically as well. So it's at their fingertips on their phone, either back at homestead or if they're travelling. It just gives them peace of mind to manage that resource.
Wow, that's amazing, because one of the things I think with any farm is leaving the farm to do anything. And if you're a farmer, taking 2 weeks off and leaving 1 or 2 people in charge is always a concern for farmers.
That's right. I think two of the our favourite stories from the trials we had of water tank monitoring. The first one was the first time our device picked up a failure, so it was a pump failure that caused a tank to run dry. And the first instinct of the farm was, "Oh, hey, Myriota, your gear's not working. It's telling me my tank's empty." And it's like, well, maybe just go and have a look and just see what's going on, because, maybe something's gone wrong. And sure enough, there had been a pump failure. Tank hadn't been fueled. And that was one of those transformative moments where you see the light bulb go off and go, right, this is super useful and valuable. My second sort of favourite story from those trials was getting some photos sent from a farmer, just as you say, who had been taking a holiday, who's sitting, on the beach somewhere enjoying a drink, and had sort of photographed himself with our application. That's a phone app, looking at his water, saying, thanks to you guys, I can actually relax on my holiday.
Which would be, I'm sure, a complete novel concept for him. That's fantastic. So I can imagine there'd be a lot of use cases where you are trialling, that farmers are trialling, that logistics companies are trialling, etc. I imagine there's lots of use cases we haven't even got to understand just yet. There's lots of predictions about where IoT's going to go and how many connected devices we're going to have around the world, in the billions and billions. Where is it in Australia at the moment? Why has Myriota been successful to date?
Yeah, I think there's a number of reasons why Myriota is getting traction. Myriota is a very customer-focused company. That stems right back to the seeds of the research program that eventually became Myriota, of realising that there was a couple of impediments or roadblocks for the adoption of these technologies in remote areas. And they primarily came down to the cost of the hardware, to either the cost directly or the cost to maintain it, and then the cost of the service. So equipment, that let's say costs $1,000 or more, and a service that costs $100 a month it just prices itself out of existence for applications that might require lots and lots of sensors, individual sensors. So for some applications, it's totally fine. You can use those solutions. But in applications where you're considering deploying hundreds or thousands of devices, it doesn't stack up. The second thing is battery life. And this has been so both cost and battery life have been real challenges for satellite. Satellite's challenging because the satellites are far away. If they're in low Earth orbit, they're 500, 600, 700, 800 kilometres away. And if they're in geosynchronous orbit, they're tens of thousands of kilometres away. So the signal's very weak, so you need to transmit using a lot of power and so forth. So that drains batteries. So this was the other sort of technological thing that we managed to solve, was being able to transmit to a satellite at very low power and then giving a battery life that's measured in years rather than days or weeks or months.
Because I assume days or weeks or months just doesn't cut it, because you still then have to go travel around. Use that farm example, travel around to replace the battery, recharge the battery.
That's exactly right.
Doesn't make sense.
Yeah, and so you either need to go and visit the site to replace the battery, which for a water tank, well, you may as well just look in the water tank. it kills the value proposition straight away.
Yes.
Or if you then have what I kind of call escalation of infrastructure, which is, all right, well, let's not have batteries, let's have a big solar panel. All right, so now we've got a big device, it's power hungry, that's mounted on maybe a pole with a big solar panel, it's got a concrete slab that you now got to put a fence around it so that a cow doesn't come and tip it over. And I'm not kidding. I've actually heard this exact story of something that started out as kind of a modest investment, but then quickly the site install cost is $10,000.
Which again blows the whole value prop.
Kills it. Exactly. So something tiny, long battery life, low cost. And that's not unique to, let's say, the use cases that Myriota is addressing. That's Internet of Things, generally speaking. That's a requirement.
Yeah, absolutely. I think I first heard Internet of Things when, I'm trying to remember, the manufacturer bought out a smart fridge that you could do stuff on, which everyone at the time went, wow, that's amazing. Yeah. But no one ever did anything with it. Is the Internet of Things now a real thing? Like, are these just leading edge, farmers or tinkerer farmers that are interested, or are we going to see an explosion, do you think, in the real use cases?
Yeah, I think as people get on to the productivity gains, cost savings of deploying these systems, I think we will have an explosion of these types of technologies. The early use case that were put forth for Internet of Things, focusing on, let's say, consumer applications in the home, some of which have come to bear, right? Things, around the house like smart lighting and whatnot, are lifestyle and convenience improvements, perhaps some energy saving through automation, no doubt. So there's a whole category of Internet of Things there. Myriota is much more focused on industrial Internet of Things, where beyond, let's say, a lifestyle or convenience benefit, there's really a productivity enhancements or risk reduction, cost savings, and then an interesting category of looking at new business models that are enabled for the user through the application of the Internet of Things. So an example of that is pivoting away from, for example, offering a thing, either so some kind of equipment, let's call it a generator, as a rental or as a purchase, and instead offering a generator service based on the data that you get from that, so you know how much it's being run.
In terms of output.
In terms of output.
Running time,
exactly. So rather than sort of the old business model of I sell you an object, there's now much more possibility of saying, well, I can sell you the service based on kind of how much of the useful life of that object you're really consuming, depending on my monitoring of that.
And that really changes the game, because when you think about the longevity of that device, it's directly correlated to how much that device is used.
Yeah, and how it's being used.
And how it's being used.
That's exactly right.
And really, from a farmer perspective, all he cares about is throughput.
Is the service.
From that generator.
That's right. No, exactly. I think there's a lot of applications like that. I think that's kind of next year. Phase. Right now it's all about efficiencies and productivity improvements. There's a lot of improvements in logistics. So if you're looking at any kind of consumable, whether that's some kind of agricultural input, whether that's fertilizer or fuel, things like that, that might have a remote store. You've got your diesel tank. Knowing what the level is, something as simple as knowing the level in that diesel tank, and in fact, even the provider of that fuel or whatever substance it is, being able to say, all right, we know that in this area they're starting to run out, they can start planning their operations, start fulfilling the forward orders, again, as a service, starts becoming very interesting.
Wow. So you referenced before about the seed of where Myriota started. Can you perhaps take us through where Myriota began?
Yeah, I think Myriota is an interesting story of the journey of commercialisation out of an academic setting. The seeds for Myriota were planted in a research program at the University of South Australia back when I was director of the Institute for Telecommunications Research, where I've been for a while. and it was stimulated by a federal government investment into the space industry back in I think 2010 through the Australian Space Research Program.
There's a fair bit of talk about space at the moment.
There
News,
is, and it's kind of topical. It's one of these cases where, with the benefit of hindsight now in history, you can kind of look at, well, what types of effects can these investments have? We had a number of commercial partners that we were considering doing some research in this general area, machine-to-machine communications. We'd identified this gap in the market for low-cost, long battery life, narrowband data way back in 2010. Mm-hmm. And then this Australian Space Research Program came online. So we bid for some funds through that program, and we were eventually successful. And ran a 3-year research program really to develop a technology to address the 3 main issues that we saw, which was massive scale global coverage, super long battery life, super low cost. And so we managed to do that. That led to a IP portfolio of 10 patent filings and a pathway to commercialisation. And commercialisation was always on the cards for this program of work. I'd previously had some exposure to spin-outs and commercialising things through my involvement with another company, Coda Wireless. And when we got this funding from the Australian Space Research Program, it was it was a fairly chunky research grant. And I looked at these funds and thought, well, it would almost be irresponsible to do anything other than to try and get an eventual commercial outcome on the back of this research. I really had a strong desire to see this not just result, let's say, in academic papers or reports that might add to the knowledge base and capability, but otherwise sit on the shelf. So there was a very strong impetus right from the start to say, right, we're going to identify a problem. We're going to talk to prospective customers at the start of the research, figure out what the gap in the market is, what's the technological roadblock, solve those problems, and then take the next step, raise money, spin it out.
So is that typical? Is that typical in the university space around research, or or is this a bit of an anomaly because of you and others in terms of looking to commercialise that early on?
I think there's a strong desire in the academic sector to bring inventions or new capability to market one way or the other. Let's say I don't see very often that kind of front-loaded approach where it's what I now call premeditated commercialisation, where you say, okay, I'm going to treat my research grant a little bit like a seed investment.
Yep.
And get my minimum viable prototype, let's say, and then take it forward commercially.
So what holds people back?
I think it's a little bit around the academic career progression in Australia. Academic system is a little bit of a closed system in Australia, and that's evidenced by data that supports that kind of point of view. I think it's about 70% of postgraduates from Australian universities are employed in academia or government. That's kind of the highest rate of retention of those highly trained staff by academia in OECD countries.
Is that right? Wow.
Conversely, Australia's got the lowest interaction rate between industry and academia in terms of collaboration. So you kind of have a bit of almost a bit of a separation. Now, there's a lot of will on either sides of that story to change that going forward, because I think there's a lot of benefit for that. But what it means today, or at least maybe back when I was in the academic environment, is the mainline path to career progression in academia is high quality research, win research grants, publish papers, sort of very classic approach. And what we're seeing more and more these days is a move to really be looking at the impact of that research. Now, there's always a tension there, because some research really requires a long time horizon to come to fruition. But, in some areas it can be very fast. And that's the case for the kind of research we're in, where you make a mathematical breakthrough for some algorithm for signal processing. It gets built in software So there's a really quick translation from idea to implementation that then becomes a product. So it's very closely coupled. So you're really pushing forward the boundaries of sort of that engineering practice, let's say. But you have to mean to do that. It helps so much to do that on purpose rather than, and I think this is the way that a lot of research commercialization is done, which is a commercialization office coming along after the fact and saying, okay, guys, invented anything good this week?
What
What do you got? All right, can we license it? No. Okay, see you later. Oh, maybe this is interesting. License it. Now, I think there's a place for that.
So the commercialization arm of the university licenses. License the technology or the patent, or how does that
that's
work?
right. So quite often that will be the case, right? So, but I think the thing that's interesting there is that sort of becomes after the fact.
Yeah.
So you've got your researchers living in the research world, doing their own stuff, a little bit disconnected. Someone comes along, pushing the broom after them, saying, "What can we sweep up here? Oh, this looks interesting. Right, let's now shop this around."
Yeah.
And that's great. Every now and again, there's like a superstar hit out of something like that. But what it prevents you from being is very strategic with the IP that you're developing. So it becomes a bit accidental.
Yeah.
It becomes a bit hit or miss. And you've got your technology transfer really consists of throwing the IP over the fence to someone to sort of commercialize it now on their terms, which is, I think, missing out for where I think the real opportunity for technology transfer, which is around movement of people who can generate IP going forward and really who embody the capability that produced the IP. And I would say that the most valuable thing that Myriota took when we spun out of the University of South Australia was not the patents. That was very valuable, but the most valuable thing were the handful of staff that came and joined the company, because that built the company, created then new jobs going forward, and created a capability in a commercial setting to innovate, which then just sets the tone for the company going forward. Then it has the additional benefit that now there's an innovative company that has a bunch of PhDs in it that are actually equipped to have a peer-to-peer research relationship with other universities, which is really critical. That's how you get really interesting academic industry interactions, when it's more of a peer-to-peer collaboration rather than let's say a research for hire, a buyer-seller kind of relationship.
So if if you think about the traditional entrepreneur and the traditional innovation that comes in those large technology organisations that we see become very successful, there's often a lot of passion for the technology that we created in our garage, and now we've taken it to market. Now we've been really successful. Does that passion, because you've taken those staff out of the university and they've been involved in the project along the way, does that passion come through then once you start to commercialise it?
Absolutely. I think there's real intellectual ownership of some of that technology and a desire to see it succeed. Now, of course, in a startup environment, that can be risky, right? So if you're too obsessed with the technology, you will just trip over yourself, right?
You'll just burn cash like this.
So I think the one of the early things we did as a company was really look at what our company values were going to be and how we were going to approach commercialization. And having been very customer focused was one of the things we landed on. But then also the idea of simplicity and keeping it real. So understanding that, the stuff, has to get to market quickly, has to solve a real user problem, which then ultimately addresses the sort of product market fit. And then the stuff, starts being a pull through by the market rather than a push through. This episode of The Self-Made Theory is brought to you by Caparezza Espresso.
I've been frequenting Caparezza for a long time, and when I say frequent, I'm there at least every day, sometimes 2 to 3 times a day. Why? Because their coffee is truly second to none in Adelaide. But what really stands out is their amazing service. Complete with traditional home-cooked pasta dishes, antipasta platters and daily specials, you will find an authentic Italian cafe experience right in the heart of the Adelaide CBD. They are also open Friday evenings for after-work drinks and pre-dinner nibbles. Just Google Caparezza Espresso for details, or you'll find them at 36B James Place in the Adelaide CBD. So what's the process? So you realised you were onto a good thing. Some patents were lodged and obviously approved at some point. What's the process of taking that from the university and spitting that out into a company? How does that process work, and how does that get funded? And do you have venture capitalists involved at that point, or does that come later?
Yeah, so in Myriota's case, we had the seeds already of potential investors already during the research program. So one of the things when I'm sort of talking to people about thinking about commercialising out of a university setting, the two things you want to do is figure out who your customers are and what their problem is, and then figure out who your investors are. Yep. Right?
Get those two things.
And do those two things before you while you're actually doing the research, because then you're interacting with a couple of really key stakeholders actually. So it was a industry consortium project that we ran, and one of the partners that came in at a sort of later stage for some of the trials and demonstrations was a company called Exact Earth, who have a business in maritime vessel tracking. And they anchored a seed round in 2015.
So for those that don't understand, seed funding versus Series A.
Yeah, so some early funding really to take the prototype that we, so we got to prototype stage, developed a bunch of math algorithms, and then embodied that in sort of off-the-shelf hardware, shown that working over live satellite links, which had been provided by this company, Exact Earth, and then really spent a lot of time putting together a business case, a business plan for saying, all right, this is what we're going to do for the next couple of years to take that package of IP, prototype and so on, and really take it through to the stage of initial product rather than initial prototype. An initial product that could be in the customer's hands, in the field, in pilots, really looking at, I guess proving out some of those use cases. One thing at this, when you're doing research, saying, okay, we think we've got something here. It's another thing to say, okay, well, here's a big list of customers. Here's what they're doing with the technology, and this is why they're using it. So getting it to that stage, that was the objective, and then really to set up for an A series investment. So our pathway, it's not, there's many ways things like this can go. It was really a strategic seed round, and then more recently, just earlier this year, a Series A round led out of Australia, out of institutional venture capital, and then a couple of corporate strategic VCs coming in out of the US, and then really now putting in funds to get the product all the way to market, build out our infrastructure, and really start the scale up of the service offering.
So imagine this whole process. This isn't just Dr. Alex with the company who's providing the investment. I imagine there's a bunch of people that are working through this process. Do you have lawyers involved? Do you have, people who are specialised in, commercialising, IP? Who's involved in the process?
Yeah. So I think we received really good support out of UniSA, out of UniSA Ventures. So the staff there with experience of setting up companies and getting things going, that really provided a lot of structure to the setup of the company. And then outside of that, so various service providers, right, from legal through to advice sort of on the financial modelling side of things, So we were fairly forthright in seeking that kind of help, because you can't. Well, it's risky to just try and do that yourself. You might be a technology expert. That doesn't make you an expert at writing contracts, and probably quite the opposite. There's those professional service providers around in Adelaide that we could look to out of based on sort of networks that we already had or could be introduced via UniSA Ventures, and those have developed into now just working relationships with some of those providers going forward. Going from a seed round to a Series A round of sort of putting that deal together, all the legal documentation, and getting that through.
So I can imagine on the day that you signed the contract for the Series A funding, which was a sizable amount of coin, which was very exciting to hear. There was probably some celebration that day, I imagine.
Yes, it was one of these like finishing the marathon. So you're very happy, but you're almost too exhausted to do anything about it.
And did you wake up the next day and go, oh my gosh, now I have to run another marathon and get this baby off the ground?
It's a little bit like that, and so that's the phase we're in now, exactly, where landing the investment is not the end of the story. Actually, it's the start of the story.
Absolutely.
And so now it's an exciting new phase of deploying those funds to build the company and scale the product out. So that's super exciting, but is a whole new set of activities now.
Yeah, I could imagine. It's pretty exciting, and it's a fantastic story for South Australia. There's been a lot of talk about space industry in general. Do you have any thoughts on where South Australia plays a role in Australia's space future?
I think it's interesting when people ask about, Australian space industry and should it be supported and so on. And Australia has a space industry, right? Because of, in spite of, I don't know. But, there's this wave of entrepreneurship and innovation, particularly in the new space area. So, companies like Myriota, whose business models are enabled by lower cost and more ready availability to space via lower cost satellites, lower cost launches, and that are commercially available. So people are just running away, innovating and coming up with stuff kind of regardless. And, I think there's a real opportunity here. Some of this, like Myriota, has long history. Myriota back to ITR at UniSA that did the FedSat mission, that runs a ground station, that has done a lot of has done support missions for flights to the space station, all things like that. So quite a long history in space in Australia, connections to defence, all these types of things. Through to young people just getting ideas and just running with something, right? Out of other environments. So it's really, really interesting, and there's a lot of opportunity. The interesting observation that I've been reflecting on this, of the role for support in space in Australia. Now, clearly, Myriota has been the benefit of government investment in the area through research grants, both generically out of a university setting, and then specifically through the Australian Space Research Program. So you can really see that line of sight from, there's a cause and effect. One of the things that, I'd really like to see is the maturation of the Australian space ecosystem, the commercial ecosystem. Right now, we are a customer of, a number of companies around the world to provide, various components or services, whether that's a spacecraft component or some other service to do with launch or to do with operations. And if you look at, and we're buying those from other companies overseas based on their capability, how long they've been doing it, what's the risk profile associated, how much heritage have they got, if it's a space component, how long has it flown for, things like that. And for some of those things, Australia's yet to get to that same level of, let's say, commercial availability of some of its offerings. And I think, that's where we see that as Myriota as a company is benefiting directly from the investments that other countries have made in their space programs, which have led those companies that we are now customers of to develop their systems for which we are now a customer.
Okay.
Right. So I'd love to see the same thing happen here in Australia, where if I'm buying a component from an overseas company, well, there's the capability here in Australia to do similar things, but perhaps is not quite yet at the same level of maturity where for a commercial offering you have the confidence to say, right, I'm going to go to this company that's just down the road and buy this particular component. But it's headed in that direction. And that's quite exciting. So, I think space industry, the new space industry is emerging kind of its own accord. And it's really, as a country, to the country really of how much support they're going to give to that industry.
It's interesting. I heard something the other day, and I'm trying to remember who told me. It might have been Joe Thorpe from Tech SA or somebody like that, who'd mentioned that in South Australia there were 63 companies either directly involved in developing technology for space or supporting companies that are.
That's amazing.
In South Australia.
Yeah,
extraordinary.
That's mind blowing, and I'm sure the story is similar. Around Australia more broadly. There's companies doing everything from designing components for rocket engines using sophisticated numerical optimization and 3D printing, through to companies designing entire engines and test firing them with a view to launch, through to companies looking at opportunities for launching from Australia. New Zealand already doing it. So it can be done. It just takes a will and the commercial need to do it. But it's definitely exciting times, that's for sure.
It is. What countries around the world are doing it well, and how does their ecosystem differ from Australia? Whether that's either in the space industry or in the university, the commercial industry, in terms of the way they bring innovation to market.
Yeah, I think we interact quite a bit with Europe, United States, Canada. Now, all of who benefit from various space agency type of programs. But there's a number of, for example, small satellites and nano satellite manufacturers, some in Europe, some in the US, have now been going for quite some time and are now really, have sort of, I would say, crossing that threshold from this is a startup that's come out of a university,
yes,
to now, this is a credible company now that they just happen to be in the business of selling bits of satellites or whole satellites, and that's pretty interesting. I think the really interesting one close to home is the New Zealand environment with getting set up so that Rocket Lab, a US-based company with a New Zealand connection, could just say, all right, we're going to launch rockets out of here. And from my sort of outsider perspective, seeing, okay, the New Zealand government saying, yep, well, we're open for business, let's make that happen. Let's just do it, which is really interesting. Then you look at, still early days for them, but that's a fair way down the track. I mean, they're getting their launch manifest booked out, and and launches all coming up, and that's a incredible example of the new space opportunities and economy at work, and in a pretty tough area, right? That's an area where if a government wants to make it painful, they basically make it impossible, and you move on, say, right, we're not going to deal with you here. So that's I think really worth looking at and say, okay, well, how did that happen?
Outside of the government making it difficult, how important is the government in any country in terms of investment and support? How important is that to bringing space to life, as opposed to private industry like Elon?
I think it's really important. I mean, let's face it, if you're sort of talking about SpaceX and Elon Musk, it's a commercial enterprise. Government's sort of one of their big customers, right? So again, so I think with space in particular, sort of as I was sort of mentioning before, getting to your first, let's say, product that's got some flight heritage behind it, so something you can offer to to companies like Myriota, who are more on the customer side. Okay, all right, I want to buy 10 satellites. I don't want to buy the first 10 you've ever made, right? So getting your product to that point of being able to have that commercially available and it's all tested and it's flown before and so on. So, what are the options there? You either sell someone on an investment to do that. Well, that's what you're doing, no matter who the investor is. But frequently internationally, working in research environments with a space agency or something like that, as part of larger programs that then get some of that technology advanced down that track really helps. And that's the kind of thing I'd love to see, just so I can be a customer for it.
Well, it's a super exciting story, Myriota. I can't ask you, I'm sure, what's next, because a lot of that will be shrouded in secrecy as you roll out your business plan. But as a proud South Australian, it's pretty exciting to see what's happening. It's pretty exciting to see what you've done so far, and we're all going to be waiting, I think, with bated breath as to what we see next come out of Myriota.
Certainly looking forward to the future. It's pretty exciting.
Yeah, it is.
On our way now, for sure. So
yeah, fantastic.
Watch this space.
Well, thank you very much for spending your time with us.
Yeah, thank you.
Cheers. Wow. Who knew there was such exciting stuff happening in Adelaide with companies like Myriota? I love hearing stories about exciting tech companies that are changing the business landscape in South Australia, in place of the traditional companies changing the physical landscape of our state by digging stuff out of the ground. It sure is exciting stuff. If you've enjoyed this episode, then don't forget to tell us what you think of the podcast. Rate us or provide comments in your podcast app, or via Instagram, Twitter or Facebook, or send us an email, podcast@theselfmadetheory.com. Until next time, keep innovating, overcoming and prospering.